All right, pre-algebra students. So today we are moving into our last lesson using exponent rules, and that is scientific notation. So we should be able to apply the properties of exponents to write very large and very small numbers in scientific notation. We're going to go over how the structure of scientific notation ties into exponent rules. And we're going to practice converting from our standard notation, our basic numbers that we know and use often, to scientific notation. And we're going to convert scientific notation to standard notation. So make sure that you are following along with your guided notes, and let's get started. So, scientific notation. Your greatest experience with this so far is probably on your calculator. You probably got numbers like this, 3.6851 E10. And you probably were wondering, what does that E mean? Well, the E stands for exponent. This E stands for times 10. So if I rewrote this in the way we use scientific notation, it would look something like this. 3.6851 times 10 to the 10 power, or to the 10 exponent. What this does is it allows us to simplify or kind of condense numbers that are too large to fit on our calculator accurately. So let's fill in these notes here. So scientific notation is a shorthand way of writing really large or really small numbers. And the size of the number really just depends on the exponent. So scientific notation is written as a product of two numbers. The first number must be between 1 and 10. It can't be any bigger. The second number must be a power of 10, or an exponent of 10. So let me give you an example. Let's say we've got 5.86. Here's the first number. It's a number between 1 and 10. 5.86 is a number between 1 and 10. And we're multiplying it by a power of 10. 10 to the, let's say, 5th power. This number will be very large, because here's what's happening with this number in scientific notation. We're basically saying 5.86 is being multiplied by 10 5 times. 10 times 10 times 10 times 10 times 10. And so this is going to move the decimal place on this number quite a ways. This is going to be a very large number. Let me show you an example of a really small number in scientific notation. In scientific notation, we represent very small numbers with negative exponents, times 10 to, let's say, the negative 5th power. This is going to be 3.14 times, well, we know that 10 to the negative 1st power is actually 1 over 10, right? So this would be times 1/10 times 1/10 times 1/10 times 1/10 times 1/10. So really, we're dividing 3.14 by 10 5 times. So that's going to be a very small number. The decimal is going to move to the left. There's going to be a lot of zeros and make it a very small decimal. So let's talk about converting these numbers. So we're going to convert the numbers we know to scientific notation. Standard notation is how we normally write numbers. Let's convert them. Let's condense them. So first we need to create a number between 1 and 10 by moving the decimal. Then we're going to count the number of times that we move the decimal. This number will be our power of 10. That's going to be the exponent on the 10. If your number is greater than 1, the exponent will be positive. So this is how we represent very large numbers, is with a positive exponent. If your number is less than 1, like a decimal, the exponent will be negative. That's how we represent very small numbers. Here's an example. So let's say I've got 3,800,000. And we want to write this in scientific notation. The first thing we need to do is determine where's the decimal right now. Well, it's at the end of all these zeros. Where do we want the decimal to be? Well, we want it to be somewhere so that we create a number between 1 and 10. And that would be right here, because we would create the decimal 3.8. Now, we're going to count the distance. We're going to count how many times we had to move the decimal. So that's 1, 2, 3, 4, 5, 6 places. Okay? Since this number is greater than 1, our exponent's going to be positive. This would be 3.8, remember the number between 1 and 10, times our power of 10. 10 to the 6th power. That's how writing numbers in scientific notation works. So let's try a few more. We're going to convert each number to scientific notation. So I have the number 1,850,000. Again, I want to identify where is the decimal in this number. It's at the end of the zeros. Where do I want the decimal to be? Well, I want it to be in a place that's going to create a number between 1 and 10. I can't move it here because I will have the number 185. I can't move it here between the 8 and the 5 because then my number would be 18.5. I can move it between the 1 and the 8. That will create the number 1.8 between 1 and 10. Now I count how many times I move the decimal. 1, 2, 3, 4, 5, 6, and I am counting the spaces in between the digits, right? So we are moving 6 places. We're moving the decimal 6 places to the left. This is going to be a positive power of 10 because I have a very large number. This number is greater than 1. So my number between 1 and 10 is 1.85. And I am multiplying it by 10 to the 6th power because I moved the decimal 6 places. Let's try number 4. This time we have a very small number. This is a number much less than 1. It's going to have a negative exponent when we write it in scientific notation. So first, identify where the decimal starts, right here. A little bit easier to figure out in small numbers. Where do we want the decimal to end up? Well, we need a number between 1 and 10. We need to move the decimal after the 1. So let's count the spaces in between. We've got 1, 2, 3, 4, 5 places. And since this is a small number, our exponent will be negative. So our number between 1 and 10 is 1. We can write 1.0 or just 1. And then times 10 to the negative 5th power. For additional practice on these, I would try out problems 2 and 3. So let's say we want to go the other way. Let's say we have a number in scientific notation, but we really need to know the exact quantity or an estimate of the quantity. Well, we're going to convert from scientific notation to standard form. So in this case, we're going to move backwards. We're going to move the decimal the same number of places as the exponent. So if the exponent is 6, we're going to move the decimal 6 places. Now if the exponent is positive, we're going to move the decimal to the right in order to make the number larger. And we're going to add zeros as placeholders if we need to. If the exponent is negative, we're going to move the decimal to the left in order to make the number smaller. And again, same thing, we'll add zeros as placeholders if we need to. So here's an example. Let's say I've got the number 0.0000531. Okay. And actually, we're going to go the opposite direction. Let's say I've got a number already in scientific notation there. Okay. So let's go 5.31 times 10 to the negative third power. Well, I know that my exponent is negative, which means I need to move the decimal to the left. And since it's negative 3, I'm moving the decimal 3 places to the left. So starting from where the decimal currently is in the number, I'm going to move 1, 2, 3 places. The decimal will end up over here. Now notice I have gaps. I create little divots when I count the places so that I know where to put zeros. I'm going to need to put 1 0 in each divot that I make. So this has been moved 3 places. My new number, if I rewrite it neatly, is going to be 0.00531. And it's really important to write all of the digits that are in the number. We're expanding the number. Let's try out a couple more examples. So we are going to convert the following from scientific notation to standard notation. We are given 7.83 times 10 to the 7th power. I'm already seeing that that is going to be a very large number, which means I need to move the decimal to the right. So I'm going to take the number 7.83 and write it here. This 7 means I'm moving 7 places to the right because it's a positive 7. So starting from my decimal, moving 1, 2, 3, 4, 5, 6, 7 places. Here's where the decimal will end up. And I'm going to fill in placeholder zeros. Okay, so here's my number, and I'm going to start from the right side. So I've got 5 zeros. All right. So my expanded number, my number in standard notation, is 78,300,000. Okay, number 8, we have the number 3 times 10 to the negative third power. This negative 3 exponent tells us to move 3 places to the left. So I'm going to write this 3. Here's my decimal. I'm going to move it 1, 2, 3 places and fill in placeholder zeros. So my actual number in standard notation looks like this, 0.003. And for additional practice, you have problems 6 and 7, as well as a chart that converts from scientific to standard form and the other way around. Go ahead and try out those practice problems. So that was our video. Thank you so much for watching. Again, please make sure you are practicing these skills in order to understand them better. Check your answers with my filled in notes in the Module 2 Notes tab of our content library, and ask for support in Math Help Desk if you need it. Thank you again for watching. Have a good day.